In this video, we are going to discuss how to use work kinetic energy theorem to find the final speed of an object acted upon by a variable force. Question 24a. A block of mass 3 kg slides under the effect of a variable force across a surface as shown below. The frictional force between the block and the surface is negligible. The block has a speed of 1 meter per second when it is located at x equals 1 meter. Calculate its speed when it is at x equals 4 meter. So here in this question, you have a block of mass 3 kg. So I will write m equals 3 kg. And it is acted upon by a force F, which is given as 0.25 x cubed. The block has an initial speed of 1 meter per second at a position of 1 meter. And we need to find its final speed when it is at a position of x equals 4 meter. So we will use the work kinetic energy theorem to find the final speed. We know from work kinetic energy theorem, work done on the block will be equal to change in kinetic energy of the block. So I can find the final speed if I know the change in kinetic energy, and that change in kinetic energy we can know by finding the work. If we have a variable force, we can find the work done by the force as W equals integral F dot dx, where we integrate this over the initial and final values of x. So we write this as integral. Initially, the block is located at x equals 1 meter and its final position is at x equals 4. So we take the limits of integration going from 1 to 4. F is 0.25 x cubed dx. Now let's take 0.25 out of the integral. Then integral 1 to 4 x cubed dx, which will be equal to 0.25. When you integrate, you increase the power of x by 1. So x to the power 3 will become x to the power 4 and then divide by the new power going from 1 to 4. Then we substitute the limits. We write work done to be equal to 0.25. First, in place of x, you will substitute the upper limit minus. Then in place of x, you will substitute the lower limit. So first we put x as 4. So 4 to the power 4 over 4 minus, now put x as 1. 1 to the power 4 over 4. And that gives me the work done by the force to be equal to 15.9 Joule. Now this work done I will use in the work kinetic energy theorem. From the work kinetic energy theorem, we can write work done to be equal to change in kinetic energy. Change in kinetic energy is nothing but final kinetic energy minus the initial kinetic energy. So I can write the work done to be equal to final kinetic energy will be half mv final squared minus initial kinetic energy will be half mv initial squared. Half m is present in both the terms here, so we can take it out as common and put the rest of the term inside the bracket. V final squared minus V initial squared. Now move 2 and m on the other side. We multiply with 2 and divide with m. So we get 2w over m to be equal to V final squared minus V initial squared. Now we move V initial to the other side to find V final. So we get V final squared to be equal to 2w over m plus V initial squared. Now take the square root. Final velocity V will be equal to square root 2w over m plus V initial squared. That will give me square root. Now substitute. 2 times work done is 15.9. Mass of the block is 3 kg and its initial speed is 1 squared. So I get my final velocity to be equal to 3.41 meter per second. So this is how you can use work kinetic energy theorem to find the speed of an object. Question 24b. A block of mass 3 kilograms slides under the effect of a variable force across a surface as shown below. The frictional force between the block and the surface is negligible. The block has a speed of 1 meter per second when it is located at x equals 1 meter. Calculate its speed when it is at x equals 4 meter. So again you have a block which has a mass of 3 kilogram and it is acted upon by a variable force F which varies as a function of x. Then you have the initial speed of the block which is 1 meter per second at x equals 1 meter, and you need to find its final speed when it is at a position of x equals 4 meter. Again we will use work kinetic energy theorem to find this. And we know from work kinetic energy theorem, work done by the force is equal to change in kinetic energy of the block. And in order to find its final speed, we need to know the change in kinetic energy. And for that, we will first calculate the work done. So I will write work done by a variable force W is equal to integral F dot dx, where we integrate from the initial to the final values of x. So we substitute W equals integral. We are going from x equals 1 meter to 4. So from 1 to 4, F is 0.10 x cube dx. Take 0.1 out of the integral. Integral 1 to 4 x cube dx. Now when you integrate, we increase the power of x by 1. So x to the power 3 will become x to the power 4 over 4. And this is going from x equals 1 to 4. Now we substitute the limits of integral. First, in place of x, you will substitute the upper limit, which is 4. Then in place of x, you will substitute the lower limit, which is 1. So we get 0.10 4 to the power 4 over 4 minus 1 to the power 4 over 4. When you solve this, you get the work done to be equal to 6.38 joules. Now we will use this work done to calculate the final speed V. To find the speed V, we will use work kinetic energy theorem. We know from work kinetic energy theorem, work done by the force is equal to change in kinetic energy of the block. Change in kinetic energy I can write as final kinetic energy minus initial. So work done will be equal to final kinetic energy we will write as half mv final squared minus initial will be half mv initial squared. Take half m as common from both the terms. So half m v final squared minus v initial squared. Now move 2m on the other side. We multiply with 2 and divide by m. So 2w over m is equal to v final squared minus v initial squared. Now move v initial to the other side. We get 2w over m plus v initial squared equals v final squared. Then we can find v final by taking square root on both sides. So v will be equal to square root 2w over m plus v initial squared. Now substitute v equals square root 2 times the work done, which is 6.38. Mass of the block is 3 kilogram plus 1 squared, which is the initial speed. And when you solve this, you get the final speed of the block to be equal to 2.72 meter per second.